Alright, so today we're going to go over some examples from our homework of how to create a line of best fit using our graphing calculator. Just to be clear, I will be following the directions that I gave you in class today. And remember that first page has an outline of the entire process, and the pages after that are a little more clear on step 1 and step 2. So when I'm going through this video, I will be using this reference in front of me, but I will not always put it on the screen. So from that reference, obviously, though, the first thing we need to do is enter our data into the calculator. So following that on the second step, what it tells us to do is the first thing we need to do is get into our data. So we hit Stat, and we choose option 1, which is Edit. And then, like it says here, and on the resource I gave you, it tells you to clear stuff out if anything's there. So I have data here that I don't need, so I'm going to go up to the top and clear those lists. And then as your resource says, you want to put the X's into L1 and the Y's into L2. So I have the ability to type those in really fast on my computer here. If you need to pause the video to make sure that you can enter that data, go ahead and pause the video. But once you've come back and have all that data entered like I do, then we're going to move on to step 2 on our list. So after we've entered the data, the first thing we need to do is make a scatter plot. Now when we're making a scatter plot, again using our reference, the first thing it says to do is make sure that we don't have any equations being graphed. So it says hit the y equals button and clear out any equations that are there. Then what we need to do is hit the second button and y equals, and that brings us to our stat plot menu. Now we're only going to make one picture. So if these other things were on, we'd want to turn them off. Remember, the way to turn them off is you simply go into them and it would look like it's off. And I would just go highlight whatever one I wanted. So if I want to turn it on, I highlight on. If I wanted to turn it off, I highlight off, and I hit enter to select that. So I'm just going back to second y equals. So here I can see that my plot 1 is on, the other 2 are off. So I'm going to choose the first plot. We always want to make sure it's on. So again, if it wasn't, you would simply select it and hit enter. Want to choose the scatter plot type of graph. The calculator can choose a lot of different types of graph. The scatter plot is the first one. It's the one that looks like the dots. So I'd hit enter to select that. Now we did this before, but we have to make sure to tell the calculator where our x's and our y's are. So I need to make sure that my calculator knows that the x's are in L1. If that was different, or if it wasn't there, the L1 button is blue above the number 1, which would mean I hit the blue button first and then the number 1. So like if I wanted to get L2, because that's where my y's are, I hit second, 2, and that brings up L2. The mark is what type of dot or box it'll put at that point, so it doesn't matter what you choose there, and the color is whatever color it'll make that scatter plot. So after I've done all that, the next thing we want to do is hit the zoom button, because we need to set up the window. In other words, we need to make sure we're looking at the right part of the graph. So there's a built-in place to zoom around the stats that we entered, so I can choose option 9, and it should bring up our scatter plot. So here's our scatter plot. That's step number 1. Now what we also need to do is once we have that scatter plot, I can see that a line does model this data. So from there, it would be appropriate now to actually do 2A, to use the graphing calculator to find the line of best fit. Now again, just using the directions that were given to me in class today, so the way that we do that is we hit the stat button, we scroll over to calculate, and I want to choose option 4, which is the linear regression. So it's a linear pattern, and we're going to have it be done in slope-intercept form. So I choose option 4. Now if you get something like this, again, what we need to tell our calculator is where are the x's stored. So my x's are in L1, or again, I could type in L1. My y's are in L2, or again, if it was missing or different, I'd hit second and 2 to bring up L2. The frequency list we're going to leave blank. The storing the equation is up to you. If we don't cover that in class, we'll cover it at a later point. And then to get the actual equation, I just hit enter to calculate. It does some math here, and then it gives me this equation. Now this equation, it's my job to write it as an equation. It just tells me what the numbers are. So it's in the form y equals ax plus b, but instead of a, it tells me that number is 0.7, or in other words, just 0.7. So y equals 0.7x, and then it tells me that value of b at the end was 75.42. I'm just going to abbreviate that. Now, just as another little thing, if you were entering, if you were going to find the linear regression button by going over stat to calculate and you chose option 4, if it doesn't bring you to this screen, what it will do is it'll bring you to a screen, after I delete this, it'll bring you to this screen. And here it still wants the same arguments. It just wants to know, as the calculator, where did you put your x's and where did you put your y's. But if it formats it like this, you have to type it. So you'd first type in your x's, they're in L1, and then comma, your y's, which are in L2. And when you hit enter, you'd get the same equation. So that's the main idea of how we find the equation of a line of best fit using our graphing calculator. Now to continue with the example, it wants us to interpret the slope and the y-intercept. So we know our slope is the number before x. So right here our slope is 0.7, and we want to make sure that's a fraction because we know that slope is always measuring the change in y over the change in x. And in this case, we know what our x's and y's are, which I'll start typing here. It says y is the temperature, and then it says that x is people. So if I'm thinking about my slope as a fraction, my slope is comparing temperature over people. So I can start reading this as like a little circle. As my people goes up 1, because that's a positive 1, the temperature will go up by 0.7. And again, that's because it's a positive number. So as a sentence, so every time people increases by 1, the temperature increases by 0.7. Now again, there's a lot of different ways that we could say that sentence, like each time the temperature increases or for every increase, but that's the general idea, is that we need to make sure that we say both numbers, the top and the bottom, and also include their labels. So that's us interpreting the slope. Now our y-intercept, we know that the y-intercept is the number at the end, and we know that the y-intercept is always a point. 0 for the x value, and the y value is 75.42. So for this example, what we can see is that we know that the x value, 0, is measuring how many people there are, and then we can see that the y value, which is 75.4, is measuring the temperature. So if we translate this to a sentence, we can say when there are 0 people, the temperature is 75.42. Now that sentence is fine. One other sentence that you might choose to include, just to better indicate that we know that the y-intercept is the starting point, we could just say the temperature starts at 75.42. I'm okay with that language if we're looking at the x-intercept. So that makes sense, right? If there's no people in the room, the temperature starts at 75.4. Now we can see our slope is positive, so as we add people to the room, overall the temperature gets more. And that's what our slope is saying. Every time we add another person to the room, the temperature will increase. So again, just a quick example of how we take our data. We'd enter it into our lists. Once we have it in our list, we set up our stat plots by making sure we have everything organized. We looked at the graph of that, and we used the option in our calculator to make a line. The last thing that we'd normally have you do is, if you wrote the equation of the line, we could graph it over our data. So the equation that I wrote, I'm just coming over here to type it in, 0.7x plus 75.42. And again, I just hit the y equals button. So when I graph it, it's just going to be the visual that this is a line of best fit. It models the data as best as it can.